Okay, so for our first problem, we're going to be looking at an exponential function and what we actually need to do in order to calculate certain values that are missing or certain information that we don't know. So this problem, a new car costs $70,000. If the car loses 7% of its value each year, how many years, rounded to the nearest hundred, would it take for the car to be worth $54,000? So the first thing we're going to do is we're going to go back to our original equations. This is a simple interest. It's not compounded continuously or monthly or anything like that. And we're going to write out the equation. So here we go. We want, or we're looking for when the car will be worth $54,000. So that's going to be our initial value. Not our initial value, but what we want to find after a certain amount of time passes. So we're going to have 54,000 equals, and now we're going to plug in the part where we use our equation in order to find out when that value would be reached. So our initial value is $70,000. As you can see, the number that we're actually looking for is smaller, so that means that this type of problem would have to be exponential decay. So the car loses, so we just confirmed what we said, 7%. So we're going to do times 1 minus 0.07 to the time we don't know. We want to know how many years, so we're going to write t. Okay? So, first thing I need to do is solve so that I can set up a logarithmic equation in order to find when this value would be reached. So the thing that's hindering us from doing that is this 70,000. So I'm going to divide by 70,000. Take out my calculator. Do 54,000 divided by 70,000. And I get 0.77. Alright, now right here, we're going to simplify what's in here. So 1 minus 0.07 will be 0.93 to the t. Now, as I told you in class and in your earlier lessons, now that we have it in this format, we can use the logarithm to solve. So we're going to do logarithm base 0.93 to the t equals 0.77. Okay? So now I'm going to use my calculator and use the change of base formula to evaluate t. So I get 3.6, and it says round to the nearest hundred, so I'll say 3.60. Now, here's what that means in the context of the problem. That means that after a little more than 3.5 years, that $70,000 car will only be worth $54,000. And 7% is actually a pretty liberal amount to get for the amount of money a car loses each year. It's probably a little bit more than that. So as you can see, over time, this is something that's losing value. Later on, we're going to look at an example of something that's actually gaining value. Okay? So this second question I want you to complete on your own. Here's what you're going to do. A new house is worth $300,000. So that's our initial value, okay? The house gains 5% each year, so that's going to be exponential growth, all right? How long will it be until the house is worth $415,000? So on one side of our equation, we're going to have how much we want it to be worth. On the other side, we're going to have the initial value, and then 1.05 to the t. And we're going to do the exact same steps as the previous problem to solve that, okay? That's the assignment I want you to do and bring into class. This is the second type of problem that we're going to look at. Okay? This type of problem actually doesn't involve logarithms, so in that way it's a little more simple mathematically to compute. But for these types of problems, you need to make sure everything's set up correctly, and then it's pretty much elementary math skills from there, just being able to use the calculator correctly and things of that nature. Okay. So Juan realizes that he has $16,500 in an account that he started 7 years ago. So right off the bat, if he has $16,500 and he started it 7 years ago, we know this is not the initial value. Okay? This is what we are looking for, what we're aiming to have. So I'm going to write that down. 16,500. Okay? The interest rate is 8%. Now, for dealing with money, if something tells you that the interest rate is 8%, you're going to assume that it's gaining 8% each time it's compounded. So how much was his initial investment 8 years ago? So here's how this has changed. Now we're looking at how much was that original investment in order to yield $16,500. So we don't know what it is, so let's put an X there. But we do know the rate of growth is 8%, so 1 plus 0.08. And we also know that this amount of money happens that he started with what he started with 8 years ago. So there's a little typo in there. This should say 8 years ago. All right, so we go ahead and solve this. This we can simplify. So 16,500 is equal to 1.08 to the 8 times x. Okay? I just moved the positions around. So 1.08 to the 8th and then x there. Okay? So let's find out what 1.05 to the 8th is. And that's 1.85. We'll keep 2 decimal places here. Alright? And then, simple enough, this is a one-step equation that we can just divide by 1.85. And we shall see what x is. Let's see. So $8,918.92. So in the context of the problem, that means that Juan initially invested somewhere around $9,000, and with this particular growth rate, he was able to reach $16,500 in 8 years. Okay, now this is the part where you do this next problem and bring it into class. So, a lucky 30-year-old young man receives a $1 million inheritance from his grandparents. If the account that yielded the $1 million paid 12% interest compounded yearly, how much money was in the account at the start? Okay? So I want you to make an assumption here. Assume the account was started when this young man was born. So assume the account started $30 years ago. Okay? So what we would need to figure out is we would need to say, okay, $1 million equals something times the amount with interest. That's a pretty high interest rate. The amount with interest to the number of years, okay, which would be 30. Okay? So I want you to do this problem. So you're going to have question 2 and question 4 that you're going to turn into me. And hopefully this video was helpful to you. And I'll see you guys with our next session.